Okay, so with proportions, when we're talking about proportions or proportionality, we talked about proportionality yesterday, and we know that proportionality means that they have identical unit rates, right? Or their ratios will be equivalent to each other. They simplify to the same value. There's another way that you're able to work a problem out when it's set up as what's called a proportion. A proportion is when you've got one ratio or one fraction and it's set equal to another fraction. That's what a proportion is called. What we can do is we can use a process called cross product. And a cross product, if it is a true proportion, meaning that the two ratios are equivalent, then their cross products will actually be equal to each other. So it's a lot simpler than having to figure out what each unit rate is going to be and seeing if those are the same. You can just do a cross product. So here's what I mean. You are taking your diagonal measurements. So I'm going to take this first diagonal, which is an 8 and a 3, and I'm going to actually multiply them. Let me zoom in a little so you can see that easier. You're going to multiply 8 times 3. And what is 8 times 3 going to give us? 24. Okay? Then we're going to do the same thing for the other diagonal. We're going to multiply the 6 and the 4 together. And what's 6 times 4? 24. So because they are the exact same value, these values are equal to each other. So this was 24, and they are equal to each other. Then that means this is a true proportion. This is proportional in terms of the relationship. It is a proportional relationship. Now, I can give an example of one that would not be proportional. So let's say that we had something like 6 over 9, and I want to compare it to something like 3 over 5. 6 over 9 compared to 3 over 5. Again, I would do the same process. I would multiply my 9 and my 3 together first. What's 9 times 3? 27. Good. And then I would multiply my 6 and my 5 together. And what's 6 times 5? 30. Notice that those values are not equal to each other. So when they are not equal to each other, then we call it non-proportional. Non-proportional or not proportional. Can't say unproportional. So these are just the ways that you're able to check for proportionality. If they are equal, when you do the cross product, then they are proportional. If they are not equal, then they are non-proportional. So what you guys are going to do is on the back of this page, you've got 4 problems. And you are going to work through those 4 problems, identifying what the cross products would equal, and does it make them proportional or not. Okay. In order for you to be able to get your candy, you not only have to say proportional or not proportional, but you also have to tell me what the values equal. Okay? Go ahead and take time to work on those. Was it recording? All right, so the first one was non-proportional because they were not equal. The second one is proportional because their cross products were equal to each other. Alice, go ahead and pick somebody for problem number 3. Eli? Proportional. Correct, okay? So we've got 8 times 15 that we're going to do, and we're going to have 6 times the 20 that we're going to do. And both of them are going to come out to being what? When we do 6 times 20 and 8 times 15, what do we get, guys? 120. Okay, so both of them are coming out to being equal to 120, which means that they are going to be proportional. Come on up, Eli, you can get yours. Ooh, whoops. All right, and Eli, pick a girl somewhere over in the other vicinity of the room. Michaela. Okay, Michaela, what did you get for problem number 4? Okay, and what were the 2 values? Very good, 99 and 96. Come on up and get your piece of candy. Okay, so we've got to multiply 9 times 11. And then we're going to multiply 16 times the 6. Okay, when we do 9 times the 11, that gives us 99. When we do 16 times the 6, that's going to give us 96. And those are obviously not the same values. They are not equal to each other. That makes it non-proportional. Okay, any questions? It's pretty simple, identifying if they're equal or not. But now what we're going to do is we're going to have a proportion, but this time it has a variable instead. So in those situations, that's when we're having to solve and figure out what would the variable have to equal in order to create equal cross products or to set up a proportion. So last year, like I said, one student said that they were taught that all they had to do was multiply the two numbers and then divide by the third value. And yes, that is true. However, you are going to this year be asked questions like, given this proportion, what is the correct equation that would be set up for it? So you're having to identify an equation there. Brooklyn and Aubrey, stop staring at each other. Okay? You're having to create an equation that would represent the proportion. So it's doing the same exact idea, the same exact concept, where you're multiplying your diagonals. We're going to first focus on the diagonal that involves the variables. So I'm going to go ahead and zoom in on question number 1 so it's easier for you guys in the back to see. So my variable here happens to be the letter t. So t happens to be paired up diagonally with the value 100. So when I'm setting this up, I know I'm going to have to do 100 times t, which just comes out to 100t. Okay, now again, I'm already being told that this is a proportion, which means that these are proportional values. So I can just set up and say that they are going to be equal. And what it's going to be equal to is the other diagonal, the other product of the diagonal, which is 11 times 11. And 11 times 11 is just 121. So now you've created an equation. So the question might ask you, what is the equation that you would set up for that proportion? The equation would be 100t equals 121. That's your equation. Now you also have to indicate how you would solve the equation. How would we solve this one-step equation? Alan? We divide it by 100, right? We got to get the variable isolated. We've got to get it by itself. So in order to isolate it, we're just going to divide by that coefficient. And the coefficient happens to be 100. Whatever you do to one side, you must do it to the other side as well. And when we do that, we get our value for t. In order for this to be a proportional relationship, t has to be equal to 1.21. And that's it. Okay, I'll show you one more example again. For problem number 2, we've got y over 5 is equal to 13 over 10. And again, we're going to identify our cross products first. We focused on the variable cross product. So our variable cross product is y times 10. So if I do 10 times y, I'm just going to get 10y. Then we focus on the next cross product. The next cross product is 5 and 13. So we're going to multiply 5 times 13, which comes out to 65. And again, these are equations that we're creating, so we're setting them equal to each other, because that's what the cross products are. They are supposed to be equal to each other if it is a true proportion. Okay, how do we solve? Divide by 10. So here's the equation that we've created. 10y is equal to 65. To solve that equation, we're just dividing by 10. And by doing so, we get our value for y. Y is going to be equal to 6.5. Y is going to be equal to 6.5. Okay, you guys are going to do problems 3 through 6 on your own. Problems 3 through 6. Boy. Gotta choose a boy. Michaela. Choose a boy. Caleb. All right, Caleb, what did you get for problem number 3? You got 3. Very good. So come on up. You can get your piece of candy. So y is going to be equal to 3. So if we're taking a look here, all we are doing is we are taking the cross product. We're going to do 12 times y and 4 times 9. That gives you 12y is equal to 36. You would divide both sides by 12 and get y is equal to 3. Caleb, go ahead and choose a girl. Quick, quick. Two seconds. 1 second. Who are you choosing? Nee? Okay, Nee, what did you get? 1.8 is correct. Come on up and you can get your candy. Okay, so here's what it looks like. You're doing 7 times k to get 7k. You're going to do 3 times 4.2, which gives you 12.6. You divide both sides by 7, and you get 1.8. All right, Nee, pick a boy. Nathan. God. Nathan, what'd you get?
W times 5. 60.
I'm sorry, that's wrong. I'm kidding. It's right. But the look on your face.
No, he said 5.
He said 5W. W times 5 is what he said. But his W does equal 16. All right. 5W is equal to 10 times 8, which is 80. You're going to divide both sides by the 5. 1 piece, dude. And you get W is equal to 16. Nathan, choose a girl. Quickly. 3, 2, 1. Choose someone.
Wrong pick. Hurry up.
Nathan, honey, you're wasting my time.
Kayla.
Kayla. Okay, Kayla, what'd you get, babe? A is equal to 18 is correct. Nathan, stop staring at her like that. It's a little creepy. All right. We've got 0.5 times the A. That gives us 0.5A. We've got 0.9 times 10, which comes out to 9. We're going to divide both sides by 0.5. We get A is equal to 18. Very good, guys. Now, this is the easy stuff, right? The proportion is already given to you. That's really simple. What gets a little bit more difficult is when you have to create the proportion yourself. Oh, yes. Okay, so taking a look. Now, I'm going to show you. It's really easy to break down if you just follow these simple steps. When you are given a word problem and you have to create a proportion, there's 2 fractions that you're going to be setting up. So here in this situation, we've got a 12-ounce bottle of shampoo, lasts Enrique 16 weeks. We want to know how long will you expect an 18-ounce bottle of that same exact type of shampoo to last him. So if he's using it at the same rate, he uses the exact same amount every single day, we know a 12-ounce bottle is going to last him 16 weeks. 18 ounces is going to last him how many weeks? So when you are setting up a proportion, you are setting up 2 fractions. And one of those fractions is going to have a missing value, a variable in it. So how you set up your first fraction doesn't matter. You get to set it up how you want to, anyway. But the way that you set up that first fraction will determine how you have to set up the second fraction. If you set them up differently, you will get the wrong answer. Even if you're like, oh, but hey, I did the cross product, I solved that part correct. Yeah, for the proportion you set up, you solved it correctly. But if you don't set the proportion up correctly, the wrong answer will be achieved. So you need to be very careful about that. It's really simple though. When you're setting up these 2 fractions, your first fraction, your first ratio, is called a given ratio. And what I mean by given, I mean it's the information you have been told. You are told everything about the 2 quantities in that situation. So the information in this problem that has been given to us is we know a 12-ounce bottle is going to last him 16 weeks. That's the information that has been given to him or to us. We have been told 12 ounces is going to last 16 weeks. Now, I can set it up however I want. I could put 12 ounces over 16 weeks. I could put 16 weeks over 12 ounces. That doesn't matter. It's up to me. My last class decided to do 16 weeks over 12 ounces. Let's go ahead and do 12 over 16 just so you can see a difference. Okay? So 12 ounces over 16 weeks. That's how we're going to set up our first ratio. Again, you could do 16 weeks over 12 ounces. Now notice, I didn't write just 12 over 16. I didn't do it like just this, where it's just the numbers. I am putting the quantities there too, the unit of measure as well, because that's really important to me, because the next part, I'm setting up another ratio, and I want to make sure that when I set that ratio up, I also put ounces on the top, and I put weeks on the bottom. I want to make sure that I line them up correctly, that ounces is equal to ounces, and weeks is equal to weeks. I want them to be directly across from each other. Okay, so this ratio is called the question ratio. This is the information that we are being asked to find. So in our question says, how long will an 18-ounce bottle last him? How long and 18 ounces? So 18 is going to go top or bottom? Top, right? Because it's 18 ounces. Ounces were on the top. So we're going to put 18 on the top. What's going to go on the bottom then? Weeks, but what am I going to put? W or X or Y, whatever variable you want to come up with. I'll just go ahead and put X so it looks different than what I say for weeks here. It's because we don't know. This is the information that is missing. That is the question that's being provided to us. So now we've correctly set this up. We have 12 ounces, 16 weeks. We have 18 ounces and X weeks. Now we just do our cross product. We multiply our diagonals. So let's focus on the variable first. 12 times X, which gives us 12X. Then we're going to multiply 16 times 18. That's going to give us, what, 288, I think? Right, 16 times 18, that's the 288. And then we just divide both sides by 12. And we're going to get that X, the 18 ounces of shampoo, is going to last for 24 weeks. And that's it. So again, you set it up, or we set it up as 12 ounces over 16 weeks and 18 ounces over X weeks. My last class did it in the reverse. They did 16 weeks over 12 ounces, X weeks over 18 ounces, but still comes out to the same value. Still comes out to that 24. Okay, so it does not matter how you set up the first one, but it does matter how you set up the second one. Does that make sense? Okay, you guys are going to do number 2 on your own. There are 13 out of 20 homes that have personal computers. So there's 13 computers out of 20 homes. If there are 60 homes, how many have a personal computer? You're going to go ahead and solve that one on your own. All right, tell me what you got, Alan. Very good, 39 computers. You can come on up and get that last one. Kayla, did you come up and get your candy? No, come up and get your candy too. Kayla gets to pick first, and then you're stuck with whatever's left over. All right, so for here, 13 out of 20 homes have computers, how many out of 60 homes? So the given information was 13 computers out of 20 homes. We've got X computers out of 60. We do our cross product and divide, and we get 39 computers. Go ahead and pack up.